Hello guys, so we are back again in our previous video. We have completed questions on AP and now we are doing some of AP questions, okay, and then we will wind up the AP. Okay, the 13 question we have completed 12 question yesterday. The 13 questions is as follow. These are basic questions, okay, then we will move to advanced questions. Okay, the questions number 13, find the sum of all the 3-digit natural numbers which are divisible by 7. Okay, so for that, first write the 3-digit natural number from where it begins. 100, 101, okay, 102, 103, 104, like that till 999, the last. Then check which are divisible, okay, which is the last number which is divisible and which is the first number which is divisible. Okay, 995, okay, then 994. Okay, and let's check which is the first number which is divisible. This is divisible. No, 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 not divisible. No, no. Okay, let's check 105. 105. Yes, it is divisible. Okay, so we got a series, and from here which one is divisible? 916, no, 995, 99. Okay, 994 is divisible. Okay, 994 is divisible. So now, okay, so we got a sequence which is 105, then 102, difference will be of 7, okay, and like that 119. Okay, moving on, the last number is 994. Okay, so we can get, we know last term, so we can get the number of terms in the sequence. Okay, so which is 105 plus n minus 1 into d is 7. Okay, so if I subtract this, I get 889 upon 7, which is n minus 1. So if I divide this, what I get? 127. 127 plus 1 will give me n, so I get n is equals to 128. Okay, after getting n is equals to 28, my last job is to get s. Okay, s of 128. 128 terms are there. 128 by 2 bracket 2a. Okay, my first term is 105 and the last term is 994. Okay, I can add them directly. What I get? 64 into this thing, which is what, 105 109, which gives me 70336. Okay, this is our answer. Okay, so such basic questions may appear, okay, and these questions you may have done in class 10th. Okay, so nothing great in these questions. Okay, now let's take the next question. Okay, the next question is as follow. It tells that find the number in the series 20, 19, 1 by 3, 18, 2 by 3. Find then the sum of which is 300. Explain the answer. Okay, so the number of terms. Okay, number of terms. Okay, find the number of, we want to find n. Okay, now first of all, it is in fractions. Okay, so I have a1 is equals to 20. My a2 is what? Is 19, 1 by 3. Okay, which, how do you calculate this? 19 into 3 plus 1 upon 3, which gives me 27. 57 plus 1 by 3, which is nothing but 58 by 3. Okay, so I got my a2, okay, which is 58 by 3. Now how I will get d? D will be nothing but 58 by 3 minus 20. If I subtract it, I'd get 58 minus 60 by 3, which gives me minus 2 by 3. So I got my d, which is minus 2 by 3. Okay, now it is a decreasing series. Okay, I came to know about this. Now I want to find s. I have 300. I want to find 300. I can directly use SN formula. N upon 2 bracket 2a. 2a is nothing but 40 plus n minus 1 into d is was minus 2 by 3. Okay, minus 2 by 3. This will become 600. Okay, 600 into 40n. Okay, minus 4n square. Okay, plus, okay, this will be, I moved that side, minus, okay, minus 2n square. Okay, minus 2n square. Okay, plus here it will be 3. Okay, then it will be plus 2 by 3. Okay, into n. Okay, so we got this. After, if I divide throughout by 2, I get this as 300 equals to 20 n minus n square plus n by 3. Now I have multiplied it by 3, I get 900, okay, into 60n minus n square plus n. Further, if I calculate this, I get 61n minus n square equals to 900, giving me n square minus 61n plus 900 should be equal to what? Should be equal to 0. So I want to find its root. Okay, its root are what? Should be 900. Okay, what are its root? 25 plus 36 is what? 11. Okay, 3 plus 6 5. Okay, so its root are n minus 25 and n minus 36. Okay, should be equal to 0. So we are getting n is equals to 25 or n is equals to 36. Now let's verify both. If I put n is equals to 25, okay, I'm getting 0. Okay, they are equal to 0. Okay, if I put here, I get equal to 0. Okay, when n is equals to 25. Okay, now let's n is equals to 25. Okay, when I put n is equals to 36. Okay, what I get? 36 minus 36 into 61, okay, plus 900 should be equal to 0. Okay, what I have? 2196 minus 2186, okay, equal to 0. Okay, so they are finally equal to, so both are valid. So n is equals to 25 and n is equals to 36, both are valid. Okay, the reason can be that it is a negative series, so after that it after 31st term, okay, after this 31st term, its value is all negative. Okay, so the sum of the number is positive, so we are taking only the positive value. Okay, now let's move on to the next question, which is question number 15. Okay, the question number 15 is as follow. Okay, this is question number 15. Okay, now what does this question number 15 tells? The question number 15 is find the degree of the expression. This is the expression 1 plus x into 1 plus x की power 6 into 1 plus x की power 11. Now what you observe, that these degrees are in a sequence. Okay, 1 6 11 101. Okay, the last is 101, so I have 1 6 11 and the last is what? 101. Okay, so I got an idea. Now let's check whether they are in AP or not. 6 minus 1 is 5 and 11 minus 6 is also a 5. Okay, so it is a AP. Okay, it is an AP. Now can I find the last term? Number of terms? Yes, easily. 101 is my last. Okay, and the first is what? 1 plus n minus 1 into my d is 5, which gives me 100 by, which is 20. 20 plus 1 is equals to n, so I get n is equals to 21. So number of term I got, which is n is equals to 21. Now we want to find the degree of the expression, okay, which is nothing but sum. So sum of 21, which is 21 by 2 bracket 2 into 1 plus 21 minus 1, which is 20 into d. D is what? D is 5. So what we are getting? We are getting 21 into, this will be 1 plus 10 into 5 50. Okay, which is giving me 21 into 51. Okay, which gives me my final answer 1071. Okay, so this is our answer. The main thing was identifying that these degrees when multiply will add on and will give me a sequence. Okay, the sequence will be like this. Now verifying whether it is an AP or not. If after verifying it is an AP, I know the last term, I can find the number of term. Then I know that n is equals to 21. For that I need to find, so maximum degree which I will have is 107. Okay, so we have done with this question. Now let's move on to the next question. The next question is question number 16, which is as follow. Find the sum of the first 24 terms of an AP if it is known. Okay, I think we have done this similar question, okay, which was using n plus 1 concept, so we will not do it. Okay, in a previous video we have done such questions. Okay, now let's move on to the next question, the question number 17, which is if an AP consisting of n terms where n is odd. Okay, so 1 2 3 like that till n. Okay, sum of all this term is s1. Okay, sum of all this is s1. Okay, s1 it is s1 or fin, and the sum of even number term is s2. Okay, now sum of even terms is s2, then find the value of s1. Now s1 is what? N by 2, n terms. Okay, 2a plus bracket n minus 1 into dd. What I have, d it is what, d it is what, d will be nothing but okay, instead of doing that, we can do, I know the first term. Okay, let's call the first term. Okay, instead of doing this, I don't know that from where it is begin. Okay, so we cannot consider that 1 2 3. Okay, so we have to assume that it is a1 a2 a3. Okay, till like that, till what, an. Okay, and an is odd. Okay, so how we will find sn? S1. Okay, s1 is what, n by 2 bracket 2a plus n minus 1. Okay, into d. D will be d only, but instead of doing this, we know the first and last term, so we can write is n by 2 a1 plus an. Okay, so I got the sum of odd natural numbers. Okay, now sum s2 will be even natural number. Now if I know this last term is odd, okay, then I surely know that n minus 1 will be even. Okay, even. Okay, and if it is n numbers are odd, okay, n numbers are present in order, so n by 1 by 2 will be the total number of even terms. Okay, so n minus 1 by 2 upon 2 into 2 into 2a plus n minus 1 into minus 1. Okay, into d, but we will not do it, we will write it n minus 1 by 4 into, I know the first a2 will be even. Okay, if e2 will be the second term which will be even, plus a n minus 1. Okay, so we got this thing. Now we want to find the ratio s1 upon s2. It is nothing but n by 2 a1 plus an. Okay, upon 2 upon n1 minus upon 4 a2 plus an minus 1. Now here the thing comes in picture that if I take the terms from both the end, okay, and from the starting if I take the second term, and from the last if I take the second term, okay, and their addition give me n plus 1, so there they are just nothing but am, and their value will be same, so this will cancel out, a1 plus an by 2 and a2 plus an minus 1 by 2, which will give me n upon n minus 1 into 2 into n upon n minus 1. Okay, now let me give you, we cannot assume the numbers. Okay, why? Because they have not given that the number are natural numbers. Okay, the sequence is natural number. Okay, like that, so we predicted a1 a2 a3, and I know that an is odd. Okay, nth term. Now if an is odd, then before that an minus 1, okay, will be even. Okay, so I took that an minus 1 is even, and second term will be even for sure. Okay, starting term is odd, and we told that a natural number, okay, is the domain. Okay, is the domain of sequence and series. Okay, so keep that in mind. So a1 is odd and a2 will be even, so a2 is the first term and an minus 1 is the last term, so a2 plus an minus 1. Now total number of terms, if n terms are present in odd, then n minus 1 by 2 will surely be the total number of terms which are even, so n minus 1 by 2 divided by 2 according to the formula into 2a to a2 plus to a n minus 1. Okay, this thing when I divided both, I know that a1 plus an by 2 is am, a2 plus a n minus 1, because the subscript on adding gives me n plus 1. Okay, so they when both divide give me 2n upon n minus 1, which is our answer. Okay, let's move on to the next question. The next question is question number 18, which says if the sequence a1 a2 a3 an is an ap, okay, then prove that a1 square minus a2 square plus a3 square minus a4 till a2n minus 1 the whole square minus a2n the square is equals to n upon 2n minus 1 into a1 square minus a2n square. Okay, we want to prove this. Now how we can do this? Okay, first thing which we can see that this sequence, okay, let it is s, it is a square minus b square, so I can write a1 minus a2 into a1 plus a2. Okay, this is the basic thing which I can observe from here, a3 minus a4, okay, into a3 plus a4. Okay, right. Similarly, if I move on till end, what I have, a2n minus 1 minus a2n into a2n minus 1 plus a2n. Okay, so this is, if a2 minus a1 we know it is a d, then a1 minus a2 is what? It is minus d. Okay, so we got this. Now if it is minus d, this is minus d until it is minus d, so I can remove minus d, which gives me nothing but a1 plus a2 plus a3 plus a4. Okay, till the end. Okay, till the end means a2n minus 1 plus a2n. Okay, so I got these terms. Okay, now I can get the sum of this. Okay, minus d, okay, upon 2n terms are there, 2n upon 2, okay, into 2a1 plus bracket n minus 1. Okay, 2n minus 1 into, okay, 2n minus 1 into d. Okay, but we have first, we know the first and last term, so why use this formula? We will go with this. If these two will cancel out, giving me minus d2 by n, a1 plus a2n. Okay, you can see this creates, okay, this creates mess. Okay, so why get into mess? Just use a1 plus tn. Okay, so this reduce my work. Okay, so I have final a and a1 minus a2n. Okay, I have this thing. Now my formula which I want is a1 square. Okay, so I will rationalize it, minus dn, which gives me a1 square minus a2n the whole square upon a1 square minus a1 minus a2n. Okay, now if I want, okay, if I want a2n, which is the tn term, which is nothing but a1 plus 2n minus 1 into d. Okay, okay, so a2n minus a1 will be 2n minus 1 into d. Okay, so if I multiply it minus, I get a1 minus a2n, okay, which is this thing, into 2n minus 1 into d. So here I can put minus d upon n, a1 square minus a2n square, okay, upon what? 2n minus 1 into d with a minus sign. Okay, now let's take the next page, which gives me what? d will cancel out, n upon 2n minus 1 into a1 square minus a2n square. Okay, hence proved. Okay, so we have proved this thing. Okay, we have proved this thing. What was our basic methodology? Okay, that we came to know it is a minus b, a plus b. Okay, after knowing that we know it is d, we move out the d part. I get the sum of 2n natural number, so 2n upon 2 into 2a1 plus 2n minus 1 into d. After knowing that it will create mess, I just use the modified version of Sn formula, which was a1 plus a2n, okay, minus d upon 2n. Then I got an idea of rationalizing it from the formula. I rationalize it, okay, dividing, I get a1 minus a2n. Then I know that a2n is the tn term. To create this, I use the tn term comps thing, and I substituted this value, okay, a1 minus a2n, which cancelled out my d value, and hence we proved the thing. Okay, now let's move on to the next question. Okay, which you guys follow, which says, if in an arithmetic progression whose common difference is non-zero, okay, sum of first 3 n terms is equal to the sum of next n terms. Okay, now then find the ratio of sum of the first 2n terms to the sum of 3n terms. Okay, so here we have n term sum, 2n terms, 3n terms, okay, and 4n terms. Okay, 4n term sum. Okay, now they are telling 3n, Sn 3n, the sum of the first 3n terms is equal to sum of the next n terms. Okay, after 3n it is 4n. So how I can write this? Okay, this will be s4n minus s3n. Okay, okay, this n terms I can write like this. So what I get? 2 s3n should be equal to s4n. Okay, if I solve this, what I get? 3n by 2 bracket 2a plus 3n minus 1 into d. Okay, which is nothing but here I have 4n by 2 bracket 2a plus 4n minus 1 into d. Here n by 2 will cancel out, and here 2 will cancel out. 3 into 2a plus 3n minus 1 into d. Here it will be 2. Okay, 2 into 2a plus 4n minus 1 into d. Now let's just multiply the value and try to get whatever I can get. 6a plus 9nd minus 3d, okay, should be equal to what? 4a plus 8n d minus 2d. Okay, so I got this. If I move it that side, okay, what I have 2a plus nd minus d should be equal to 0. So what I have, 2a is nothing but n plus 1 into d. Okay, so I have 2a nothing but n plus 1 by d. Now let me put it as a. Now let's move on. We want to find the ratio of, okay, this is the previous one. Let me draw a line. Okay, we want to find the ratio of s of first 2n terms, okay, s2n upon the next. Okay, next how we can write? Next will be what? S4n minus s2n. Okay, like this way we can write. So if I write this 2n upon 2 bracket 2a plus 2n minus 1 into d upon, okay, 4n upon 2 bracket 2a plus 4n minus 1 into d, okay, minus 2n upon 2 bracket 2a plus 2n minus 1 into d. Okay, so I got this. N by 2 will divide, okay, n by 2 by 2. If I take this thing out in from the both, I get 2a plus 2n minus 1 into d upon, this will be 2 into 2a plus 4n minus 1 into d. I know it is quite quite calculative. Minus 2a minus 2nd plus d. Okay, okay, so now let's just calculate it. Then I will calculate the bottom thing first. 4a plus 8nd minus 2d minus 2a minus 2nd plus d. Okay, so what I get? 2a plus 6nd plus minus d. Okay, so what you can see, 2a plus 2n, okay, 2n 4n, okay, we have 4n minus, so I can write this as 4n minus, okay, this will be 4n 8n, okay, in 8n minus 2n, which is 6n minus 1 into d. Okay, I have this thing upon, okay, I got this thing, okay, finally, okay, I have got this thing finally. Okay, so we are getting this thing on solving denominator. Now let's put it again. 2a plus 2n minus 1d upon 2a plus 6n minus 1 into d. Okay, so we are getting this thing. Now can I substitute 2a value from here? Yes. So what I have, 2a I have n plus 1, you can say nd plus d. Okay, here I have 2nd minus d upon nd plus d, 6nd minus d, which gives me 3nd upon 3nd, okay, 3nd 2, okay, nd plus 2nd, okay, this will be 7nd, 3 by 7, okay, which is giving me 3 by 7. So we are doing some calculation mistake, I guess, because of which we are getting this wrong answer, which is 3 by 7. Okay, where we are doing some mistake, let me check. So I am thinking that we are doing some mistake, okay, because of which our answer is coming not. So let me try again, because our answer should come right. Okay, so s3n was what? S4n minus s3n. Okay, so 2s3n is equals to s4n. So what we have? We have 2 into 3n by 2, okay, into 2a plus 3n minus 1 into d should be equal to what? 4n by 2 bracket 2a plus 4n minus 1 into d. Okay, so what we have, 3 into 2a plus 3n minus 1 into d. Okay, 2 into 2a plus 4n minus 1 into d. Okay, so what we have, 6a plus 9nd minus 3d should be equals to 4a plus 8nd minus 2d, which gives me 2a plus nd minus d should be equal to 0. So we get 2a is equals to 1 minus n into d. Okay, so this was our mistake. We are getting this wrong, okay, because of this thing. Okay, so now let's just use this thing. What we were on this thing. After calculating, what we got, 6. Okay, let's just calculate it again. We got the bottom as 2a. Okay, let's just do it again. Why? What was the last? S2n upon S4n minus S2n. Okay, now let's me calculate this part first. Is nothing but 4n upon 2 bracket 2a plus 4n minus 1 into d minus 2n upon 2 bracket 2a plus 2n minus 1 into d. After this I have 2 into 2n into 2a plus 4n minus 1 into d. Here n into 2a plus 2n minus 1 into d. Let me take the n common. So I have 4a plus 8nd minus 2d. Okay, and minus 2a minus 2nd. Okay, plus d. Okay, so it gives me 2a plus 6nd minus d into n. Okay, similarly let's calculate the S2n. What we have, n, 2n upon 2 n into 2a plus 2n minus 1 into d. Okay, which gives me 2a plus n minus 1. So n will cancel out, which give me 2a plus 2n minus 1 into d upon 2a plus 6nd minus d. Now let's substitute the 2n value. 1d minus nd plus 2nd minus d. What we have here we have d minus nd plus 6nd minus d. So let me calculate this part here. Okay, this thing will cancel out. Okay, this will give me nd, and here what we have, this will give me 5. Okay, 5 nd. So what we have, 1 by 5. Okay, so 1 by 5 is the answer. Okay, so this is the answer. Okay, what was our mistake? We were calculating this value wrong. Okay, so we predict it out and let's solve it again. Okay, so let's move on to the next question. The question number 20. The question number 20 is as follow. The sum of n terms of two arithmetic progression are in the ratio 5n plus 4 is to 9n plus 6. Okay, now sum of n terms of 2. Now two arithmetic progression, the a can be different, the n are same. Okay, d can be different. So let me take the first arithmetic progression as n by 2 bracket 2 capital A plus n minus 1 into capital D. Okay, then the next one is n by 2 bracket 2 a small n minus 1 into small d. Okay, so this thing the ratio is what, 5n plus 4 upon 9n plus 6. Okay, find the ratio of 18 term. Sum of n to 2 to find the ratio of 18 term. Okay, so 18 term means n minus 1, it should be which term, 17th. Okay, it should be 17 term. So if I take 2 will cancel out. Okay, if I take a plus n minus 1 by 2 d here. Okay, a plus n minus 1 upon 2 into d here. Okay, this should be 5n plus 4 upon 9n plus 6. Okay, now this n minus 1 by 2 should be equal to 17, because we want this is equal to 17 term, the ratio of 17 term. So n minus 1 upon 2, this is the trick part, because listen what I'm telling, that the ratio of 18 term is n minus 1, which is 17 term. Okay, so when I find the sum, it should be 17 also, but here it is n minus 1 by 2, so I am equating it to 17. So we are getting n is equals to 34, okay, plus 1, which is 35. Okay, so we got 34, okay, 35. Okay, so what we can do next, we want the ratio, we got the n value, so 5 into 35 plus 4 upon 9 into 35 plus 6, okay, which will give me 179 upon 321. Okay, so this is our answer. Okay, so let's move on to the next question. The basic thing was it is 17 term, this should also be 17, so we equated it. In such problem we do such things. Okay, this type of problem is unique. Okay, you have to keep in mind this type of problem. In first attempt you cannot solve this problem, it is normal. Okay, now let's move on to the next problem. The next problem is, if n arithmetic means are inserted between 2 and 38, okay, then the sum of the resulting sequence is obtained as 200. Then find the value of n. Okay, if n arithmetic means are inserted between 2 and 38, okay, n arithmetic means obtained as 2. Okay, now we know a plus b upon 2 into n is sum of inserted arithmetic mean, okay, which is given as 200. So 200 into upon a plus b by 2, okay, which is nothing but 40. 38 plus 2, between the two numbers a and b, between a and b they have inserted whose sum they have given 200. Okay, so this is 40 a plus b into 2, which should be n, which gives me 10. So n is equals to 10. This question was very easy, just on the basic concept of summation, sum of arithmetic means inserted between two numbers a and b. We have already discussed how it appears and how we have calculated its formula. Okay, now let's see the 22 question. Okay, which is this, which says if Sn is equals to np plus n into n minus 1 into q upon 2, where Sn denotes the sum of the first n terms of an AP, then find the common difference. Okay, now this question, so if I, in this Sn, if I compare it with n by 2 bracket 2a plus n minus 1 into d, how will I compare when I have n minus 2 outside? So if I bring n by 2 outside, what we have, 2b plus n minus 1 into q. So what you can see from here, and n common also. Okay, what you can see, d is nothing but q. They wanted us to find the common difference, which is q. Okay, so we have done this question. Okay, moving ahead, we have this question. Okay, which is question, solve the equation x plus 1 plus x plus 4 plus x plus 7, okay, till x plus 28. Solve means you have to find the value of x. Okay, so how we can do this? You can easily see the difference is nothing but 3, and if I take 1 plus 4 plus 7 plus like this till 28, okay, it is equals to 155. X is common. Okay, this is just a series. Okay, sum is given. Okay, now we want to find the tn term. Tn term is x plus 28. We have the first term x plus 1. Okay, if you can ignore the d, fine, there is no issue, into n minus 1 into d, which is nothing but 3. Okay, so xx will cancel out, giving me 27 by 3 n minus 1, which will give me 9 plus 10. So we got n is equals to 10. So we want to find s10, which is given 155. Okay, I put it earlier. 5 into 2a, 2a was 1, 2 plus n minus 1, okay, means 9, into d means 3, okay, upon. Okay, so we have done this. We want, okay, I will put it x plus 1. Why? Because we want to calculate the x value. So into 2, okay, let me write it. 5 into x plus 1 into 2 plus 9 into 3, okay, this is equals to 155. When I divide it by, I get 31. It should be equal to 2x plus 2 should be equal to 27. If I subtract this, I get 4 is equals to x plus 1 into 2, which gives me x plus 1 equals to 2, which gives me x is equals to 1. So x is equals to 1 is the answer. Okay, so you can look it like this way, okay, or look it like this way, but for finding x you have to substitute x plus 1a, okay, a as x plus 1. Okay, so let's move on to the next question, the question number 24. Okay, the question number 24 says as follows: if the sum of first 10 terms of an AP is 4 times the sum of, okay, if the sum of first 10 terms of an AP is 4 times the sum of first 5 terms, then find the ratio of the first and the first term and common difference. So they are telling me to find a by d. Okay, they have given that this is equal to 4 times first 5 terms. Okay, 4 times the sum of first 5 terms first. Okay, so it is 5 into 2a plus 9 into d. Okay, this should be equals to 4 times means 2, it will be 10. Okay, 2 into 2a plus 4 into d. Okay, this 5 will cancel out this 2a plus 9d, which gives me 10a 8d. Okay, so we have 8a into d, so d is equals to 8a. So we want d is equals to, d will be 1, this will be 8. Okay, so we are getting d is equals to what? So we want to find a 5 to 2a plus n minus 9d is equals to 5 into 2 4a. Okay, 4a, this should be 4a. Okay, this will cancel out this, which will give me 2 to 4a, and this 8a. When I move this that side, I will have 2a, which gives me my ratio a by d as 1 by 2. Okay, so this is the answer. This is the answer. I mostly commit some small mistakes during solving, so please don't do this thing. Okay, okay, so let's move on to the next question, the question number 25, which says sum of n, 2n, 3n terms of an AP are s1, s2, s3 respectively. Prove that s3 is what? 3 into s2 minus s1. So let's just first calculate s3. It is what? 3n by 2 bracket 2a plus 3 minus 1 into, sorry, we want to prove, okay, but what it is? It is 3n. Okay, so I will put 3n, okay, into d. So 3n by 2, 2a plus 3n minus 1 into d. Okay, now remember the sum of n, 2n, 3n terms of an AP are s1. So sum is s3. Okay, and the position means at what n? N is 2, 2n, 3n. Okay, don't get confused and put s3 is equals to 3n. Okay, childrens mostly do these mistakes. Okay, so this thing which I have got, okay, I want to prove s2 minus s3, okay, into 3 should be equal to this. But before that, s2 is what? N into 2a plus 2n minus 1 into d minus what? N. Okay, and here we have, okay, n by 2, keep it n, 2n by 2, keep it 3n by, okay, s, okay, this is sn by 2 bracket 2a plus n minus 1 into d. Now if I take n by 2 common, because here both have n by 2, so n by 2, 3n by 2 is outside. What we have? 4a plus 4nd minus 2d, okay, minus 2a minus nd plus d. Okay, what I have? I have 2a plus 3nd minus d. Okay, so what? Into 3n by 2, which gives me 3n by 2 into 2a plus 3n minus 1 into d. Okay, so we got this. So this is our answer, 3 into s2 minus 1, it is equal. So hence proved. Okay, hence proved. So approach was what? I just calculated the both side value and I got it equal. So that was the main part. Okay, now let's move on further. The question number 26. Okay, the question number 26 says as follow: let Sn denote the sum of n terms of an AP if S2n is equals to S3n. Okay, 3 times Sn. Okay, S2n is equals to 3 times Sn. Then find the ratio of S3n upon Sn. Okay, S2n is what? 2n upon 2 bracket 2a plus 2n minus 1 into d should be equals to what? 3 into what? N by 2 bracket 2a plus n minus 1 into d. This n by 2 will cancel out, giving me 4a plus 4nd minus 2d. Okay, which is here it will be 6. Okay, 6a plus 3nd minus 3d. Okay, 6, if I cancel out 2a, this will give me nd. If I bring, this will be d. Okay, so I am getting n plus 1 into d is equals to 2a. Okay, one thing. Now we want S3n upon Sn. What we have? N by 2 will cancel out from both sides, so 3 will be here, and here it will be 2a plus 3n minus 1 into d upon what? 2a plus n minus 1 into d. Okay, in sequential series you should be fast in calculating, because here calculation part is big. It is means more than what quadratic has. Okay, so yeah, if I put n plus 1, okay, here 2a and nd plus d plus 3nd minus d upon here same nd plus d plus nd minus d, what I get? 3 into this will be 4nd, okay, upon what? 2nd, which gives me 2. This is 6. Okay, so answer is 6. 6 is the answer. Okay, 6 is the answer. Now let's move on to question number 27. Okay, which says as follow: the ratio of sum of m and n terms of an AP is m square raised m square upon m square by n square. Okay, then show that the ratio of mth and n term is 2m minus 1. Okay, the ratio is 2m minus 1 and 2n minus 1. Okay, so sum of so Sm upon Sn, okay, is what? M square by n square. But let me write it: m by 2 bracket 2a plus m minus 1 into d upon n by 2 bracket 2a plus n minus 1 into d. Okay, now it is m square upon n square, right? Now if you see, m will cancel out, 2 will cancel out, which will give me 2a plus m minus 1 into d upon 2a plus n minus 1 into d should be equal to what? M by n. If I multiply both sides, I get 2an plus m nd minus nd should be equals to 2am plus 2md minus md. Okay, so what I have this, okay, 2m, why here it will not be 2? Okay, so this 2 will cancel out, okay, which will give me m minus n into d should be equal to 2a m minus n. Okay, m minus n will cancel out, giving me d is equals to 2a. Okay, now tm upon tn, okay, which I want is what? A plus m minus 1 into d upon a plus n minus 1 into d. If I put d is equals to 2a, a plus m minus 1 into 2a upon a plus n minus 1 into 2a. Okay, 2 will cancel out, a if I take common here, it will be m plus m, 2m minus 2 upon 1 plus similarly here 2n minus 2, which will give me 2m minus 1 upon 2n minus 1. So we proved it that the ratio should be 2m minus 1 upon 2n minus 1. Okay, hence proved. Okay, although you can use the other approach which we used in our previous problem, which if I equate m minus 1 by 2 is equals to p minus 1. Okay, and then I will get m minus 1 is equals to 2p minus 2, which will give me m is equals to what, 2p minus 1. Okay, you can substitute this, and if it is true for m p term, then it will be true for m term. Okay, like that way. But this I find it simple. Okay, I am going with simple approach. Okay, this may, because in this problem many teachers they directly tell you replace m by 2m minus 1. Okay, like that, but they don't tell you the reason. Okay, so this is the simplest approach possible of this problem. Okay, now let's move on to the question number 28, which says find the sum of n terms of the series. Okay, 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square dot dot dot. Okay, now here you see n is even. Okay, this second even, what I see, even term is negative. Okay, like 2, 6, 4. Okay, and odd term is what, positive. Okay, now if I say the last term, okay, if I say case 1, if the last term is even, then what it will be, 1 minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square, then in the end it will be n minus 1, like that. Minus what, n square, because last term is even, so minus sign, minus will come, minus n square. Okay, and it is n minus 1. How I came to know? By observing the pattern. It is n minus 1. If it is 4, it is n minus 1 square. Okay, like that. Now if you see, I can write it 1 minus 2 into 1 plus 2 plus 3 minus 4 into 3 plus 4, like that, and so on. I can write here n minus 1 minus n, okay, into n minus 1 plus n. Okay, like this. And here if you see, it is minus 1. So if I take minus 1 common from all the, what I have, 1 plus 2 plus 3 plus 4 plus till what, n minus 1 plus n. Okay, so minus 1, then sum of n natural number is what, n into n plus 1 by 2. Okay, just if it is n minus 1 natural number or whatever, just replace n by that number. Okay, so minus n into n plus 1 by 2 if n is even. Now let's take the case when n is odd. Case 2, if the last term is what, odd. Okay, we have odd. So what we can write this sequence, 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square, which gives me till this will be negative n minus 1 the whole square, and after this n minus 2 the whole square, okay, will be positive, and this will be positive n square. Okay, so if I consider this thing, okay, what I have, 1 minus 2, 1 plus 2 plus 3 minus 4, okay, 3 plus 4. Similarly, if I move on, what I have, n minus 2 minus n plus 1, okay, into n minus 2, okay, n minus 2 plus n minus 1, okay, this, and plus n square. Okay, so here again we get minus 1. Okay, so if I remove the minus 1 outside, okay, from this what I have, 1 plus 2 plus 3 plus 4 till what, n minus 2 plus n minus 1, okay, plus n square. Now if I use the formula n into n plus 1 upon 2, but here n will be what, n minus 1, so minus 1 into n minus 1 into n minus 1 plus 1 upon 2 plus n square. Okay, so here what I have, I have n minus 1 into n, okay, minus upon 2 plus n square, okay, which gives me minus n square plus n, okay, plus 2n square upon 2, which gives me n square plus n upon 2, which is nothing but n into n plus 1 by 2. So we have proved for odd it is what, it is n into n plus 1 by 2. Okay, so we have done with this problem. Okay, question number 28. Now let's move on to question number 29. Okay, which says as follow, which says the interior angles of a polygon are in the arithmetic progression. The smallest angle is 120 degree and the common difference is 5 degree. Find the number of sides of the polygon. Okay, now if you don't know the interior angle formula of polygon, then you cannot solve this problem. Seriously, the formula is n minus 2 upon 180. Okay, it is 360 total angle divided by the number of triangles which can be formed in the quadrilateral, okay, in the polygon. Okay, it should be equal to what? It is told that first angle is 20, then the next angle is 125, because the difference is then 130. Similarly it goes on. Okay, so if this is the sum of interior angles of polygon. If I want to write its sum, it is what? N by 2, okay, into 2 into 120 plus 2 plus n minus 1 into d is what? 5. Okay, this is what? N minus 2 into 180. This will become 360 into n minus 2, okay, should be equals to what? 240 into n plus n square minus 5n. Okay, this is 360 n minus this okay, this if I divide it throughout by 5, what I get? N minus 2. Here I have 7 the 35, 2 the, okay, this will be 4 the and will be 840. Okay, 8 the 40. Okay, n plus n square minus n. Okay, if I 72n minus this will be what? 40. Okay, 144 should be equal to 48n plus n square minus n, which gives me that if I move it, that's okay, if I move all the things, this is 47n minus 72n plus 144 should be equals to 0, which gives me what? 25. Okay, 25n minus 25n plus 144 should be equals to 0. Okay, so okay, 16. So we get n minus root as n minus 16 and n minus 9. So now two answer we are getting: n is equals to 16 and n is equals to 9. Now if I put n is equals to 16, then 16 minus 2 into 180, okay, which is 14 into 180, and you can see it is greater than what? It is greater than, okay, it is greater than, okay, we cannot predict it by checking the here this sum of this 16. Okay, we want to find the 16th angle. Okay, we want to find the 16th angle, which will be what? First angle plus 16 times d. Okay, 15 times, okay, 16, okay, 15 times d we want to find. Now what I have? 120 plus 15 into d is what? 5. Okay, d is what? 5. So if I add this, I get 195 degree. Okay, and you know that angles of a polygon cannot be greater than 180, but here we are getting 195 degree. Okay, for n is equal, for ninth, what I have, we can find a plus 8d, okay, which will be ninth. So 120 plus 8 into 5, which will be nothing but 120 plus 40, and it is less than 180. So this is possible, while this is not possible, because angles, interior angles of a polygon cannot be greater than, okay, 180. So we have proved this also. Okay, polygon like this stuff, okay, not greater than 180. Okay, so what we have concluded, n is equals to 9 is the answer. Okay, now let's move on to the next question, which is question number 30. Okay, which is question number 30, which says as follow: 150 workers were engaged to finish a piece of work in a certain number of days. 4 workers dropped the second day, 4 more workers dropped the third day, and so on. Because of this, it took 8 extra days to finish the work. Find the number of days in which the worker completed the work. Okay, now let the work is completed in n days, right? N days. So what we have? Sn is nothing but n by 2 bracket 2a plus how many workers? Okay, now if I draw sequence, okay, I get 146, similarly 142, because every day 4 people are dropping out. Okay, so what I have? N by 2a is 150 into n minus 1 into d is what? My 4, d is 4. Okay, 1 4, okay, minus 4, d is what? Minus 4. Okay, 150. So d is minus 4. Okay, now let me calculate. N by 2 bracket 2a plus this is the work they are completing. Okay, so in n days, okay, which I told. So n minus 1 into minus 4, which if I put the value I get 150, means 300 minus 4n plus 4. Okay, which is if I divide it by n I get 150 minus 2n plus 2. Okay, which is what, n into 140 152 minus 2n. Okay, 152 minus 2n. Okay, so okay, so now if so let me take it as a. Now let what they have told, it takes 8 extra days to finish the work. Okay, because of this 4 workers dropped out. So it should, if they were not dropped out, okay, then it would have been 150. Okay, total number of workers into n minus 8. What I have told, we have taken n days to complete, but it will be 8 less than should be equal to what, n into 152 minus 2n, which gives me 150 n minus. Okay, let me calculate. Okay, what I think, I have an idea what we do. 150 into n minus 8, okay, should be equals to n into 152 minus 2n. Okay, let me take the next page. If I divide, means here 2 take common and divided this, what I get, 75 into n minus 8. Okay, should be equals to what, n into 76 minus n. Okay, then what we have, 75 n minus 8 into 75 should be equal to what, 76 n minus n square, which gives me minus 8 into 75 should be equal to n minus n square, which in the end gives me n square minus n minus 600. Okay, should be equal to 0, which is nothing but n minus 25. Its root are n minus 25 and n plus 24, should be equals to 0. So we are getting n is equals to 25 and n is equals to minus 24, and this value will be rejected because number of days cannot be negative. So n is equals to 25 is the answer. Okay, so we are done with AP. Okay, now we will discuss a eccentric in the next lecture, and relation between SN and TN. Okay, some basic things and some more few questions of high level. Okay, then we will wrap up the AP and move on to GP. Okay, so thank you. Okay, we will see you in the next lecture. Till then, take care. Okay, bye.